I'm going to say a few things. I'm going to turn it right over to you next.
Okay, perfect.
Okay. I think it's recording. There we go. All right. All right. All right. Thanks everyone for joining us. Looks like we got a pretty good crowd out there. So I'm going to kind of kick this off pretty quickly, meaning that we have the calendar filled out on meetup.com for the remaining dates of 2021. Of course, when it comes to virtual versus in person, there's no sign of going in person yet for a while. And also, I think we're going to be still looking for a home when it comes to going back to in person. So yeah, if you're interested in giving a main talk or a lightning talk or sponsoring, go ahead and check out the calendar of the different dates and reach out to me or Scott Spradlin if you're interested. So Lindsay, I'm going to turn it over to you to say a few things about Adaptive.
Yeah, absolutely. Thanks, John. And thanks for having me tonight, guys. My name is Lindsay Trammell. I am a recruiter with Adaptive Solutions Group. We are a IT staffing firm here in St. Louis. We're actually headquartered in St. Louis. We've got a couple other locations in both Kansas City and Denver as well. But we are sponsoring the meetup tonight and sponsoring the giveaway. So just kind of wanted to hop on and say a couple things. In addition to sponsoring the meetup, I did just kind of want to let you guys know we are working on a large number of .NET positions actually here in the St. Louis area right now. Seeing a huge kind of surge in the market as far as a need for .NET developers of all shapes and sizes. So if you are in the market or you know anybody in the market, please feel free to reach out to me. We're working on everything from mid-level to architect level positions, both contract, and we actually have a strong number of full-time positions available right now as well. Some on-site, some 100% remote. We've got a lot of exciting stuff working with both enterprise level companies, but we've got a couple startup clients as well that are working on some really exciting things in the .NET realm as well. Some clients working with AI and robotics. A lot of people moving towards the Angular and React on the front end. So pretty much any kind of .NET role you can think of, we probably have it available. So like I said, if you're in the market or someone you know is in the market, I'm going to put my email in the chat here, so feel free to reach out to me. And then as far as our giveaway tonight, we are giving away 2 $50 Xbox gift cards. So again, if you would like to enter that giveaway, go ahead and send me your email. You can email it to me or just put it in the chat, either one, and you will be entered for that. And I will be picking a winner randomly tomorrow, and I will let you guys know, and you will be sent that gift card. But if you have any questions for me, either about just the market and what we're seeing, or Adaptive, anything like that, please feel free to send me an email. I'd love to hop on the phone with you or whatever you're comfortable with. So but thanks again for having me. I'm gonna stay on here for a bit and get everybody's emails collected, but I'm excited to hear Scott speak and see what you guys got going on. But
all right, thanks, Lindsay.
Yeah.
So you're gonna put your email in the chat, and then people are gonna email you, and then you're probably gonna do a drawing sometime tomorrow or something like that.
Yes, I will pick a email address tomorrow, and you will be the winner of the gift cards.
Sounds good. And just kind of vouch for Adaptive. I worked with Adaptive in the past, and they're a great organization to work with, so highly recommend them.
Thanks, John.
All right, Clint, before we get to Scott and talk about .NET 5, let's hear what you got. Right. And I recommend everybody kind of muting themselves and probably even turn off your camera here to give Clint your full attention.
All right, thanks, guys. All right, so Polaris is a Microsoft partner here in St. Louis, and we were approached kind of towards the end of late last year, early this year, to partner with Microsoft to do something along the lines of innovation. I think this quarter's motion in the field is to talk about how to innovate on top of the Microsoft stack, and that includes a lot of the things coming in .NET with Blazor, with the .NET 5 amazing features. My favorite being single file compilation and linking. So we thought, we'll put something together, but where do we start? And I started looking around and poking around, and lo and behold, I find this website, or it's actually a GitHub repo that has an entire workshop already built. And so rather than build some stuff ourselves and do a mediocre job, we thought we'd start with this. And So we've been playing around with this for probably the last 3 or 4 weeks and just digging into what's in there. And I've got to tell you, it's pretty freaking amazing. It is not only a nice working example, but it is completely fully documented as to how to download it, set it up, every piece of the key technologies involved, both back end and front ends in iOS, Android, and web. There's a full guided walkthrough. I mean, it would have taken us months to put this together. So to be able to work with Microsoft to help bring something like this and let folks try it out is pretty awesome. So that's what I thought I'd show you guys today. Take about 15 minutes. We'll go through some of the tips and tricks of how to get started with it. So just some of the stuff in here. There's more than I can go into, but it touches on how to deploy app services, which are basically where you build your APIs and endpoints for web, as well as JSON-based backend services, microservices. They try Cosmos DB for some of the rich data storage in JSON format. They use Azure Storage to store blobs, and they're using queues as well. Some Azure Functions to do some automatically triggered stuff in the background. Cognitive services to take a look at images, find the subjects of the images, and when they're manipulating them, make sure that those subjects stay inside the boundaries of the sizes of the images as they manipulate them, move around, reshape them, resize them. Some Azure Search on top of Cosmos DB as well. API management, putting your web APIs and backends out there in microservices and having a brokerage on top of those to do metering, to do load balancing, all kinds of good stuff. Active Directory, if you want to integrate into a corporation and your organization's membership, you can plug this thing in and go to town. A bot service, I mean, you can see Azure DevOps and how to deploy this stuff in both mobile with Xamarin, as well as looking at App Insights and the mobile App Center. So just an amazing package of work and body of work. So we couldn't help but get excited about it and want to show it off. So I'm not going to go through too much of the architecture, but you've got on the top end, you've got several different front ends, both iOS and Android, as well as a web browser front end. Active Directory is connected to manage login, logout, and account membership. You got your APIs, several different flavors, web APIs, some app services, a chatbot as a service, some Azure Functions, and even some logic apps, and tons of backends all on top of Azure. So again, just an amazing, I say amazing value for your dollar, right? It's free. So let me show you a quick spin around. I've just gotten started on this, so I can't show you everything because I don't know how it all works yet, but I'm walking through the tutorial myself. But what you start off with is building your backend web API. It's got a really nice, simple little domain model. The idea behind the project is it's for a maintenance department at some kind of manufacturing facility where you've got some jobs to go take care of and repair equipment. You've got some equipment. There's employees and customers involved in the requests and response pipeline. The jobs have photos attached to them so that you can see that the work was done on a particular part or a particular piece of equipment. So nice, simple little domain model. Small number of controllers. There's a job controller, parts, photo management, some search, and a little bit of status. So super simple, and again, I'm not going to get too deep into the code, but I just want to show you just how easy to set this up. So it's already got Swagger built into it. So you literally download this, compile it, follow the instructions to set up over on your Azure side. You can set up your backends, both the API itself. I've got it already deployed, but you'll get an endpoint to deploy the API, your Cosmos database where you can have your data stores for your different parts of your jobs. I'll give this a second to come up. And yeah, here we go. So here's our Cosmos maintenance database. And we've got some jobs in here. I think I've got a few already populated in here. So yep, you can see some sample data, which the demo code creates. If the database is empty, it goes ahead and splats those into there so you have some data to work with. And the backend stores, it uses some blobs. I've got a set of image icons ready to go, or the containers ready to go for those, as well as a queue setup so that when you upload an image, it will automatically process that photo, find the subject of the photo, keep that centered, and resize it down to a small as well as an icon version of the file. And an Azure function is what does all that work. So it's just, I mean, amazing what you get in this little sample. So I've got it up and running. You can see, so the API, we can do a quick get to call it. Let's see, try it out. If you call it without a parameter, it gives you the full set of data. You can see it all working here. And if you want to do a little bit more, you can there's also part of the tutorial which uses Postman to set up the same thing. So again, same service running. This time I'm hitting the one out in the cloud I've already published. You get a little ping, you can get a list of jobs. You see the data down there. And if I want to upload a photo, let's see if we can do this in real time. So let me go grab the file again just to make sure I got a fresh copy. And I think it's, there it is. So I've got this demo airplane file. And we might be able to see this. So what this one is going to do is going to upload this file as a large file into the file blob store. A function is going to pick up on that, detect that it's been uploaded, automatically process the photo, look for the subject using the AI, cognitive AI functions, find the subject, recenter and size the photo to a smaller file as well as an icon, all in the background. So let me send that up there. And there it is. It sent back the record for it. And let's see if we can catch it in time, guys. Let's go back over to our queue. Let's see if there's anything in it. Yep, there's the job that just got created. And in a second or two, we should be able to see the function kick in. We'll give that a second. It'll happen in the background. Oh, I think it just popped. And then over in our blob store, let me find our blobs. In our containers, we'll see the large file. That's the one we originally uploaded. And if that function kicks in time, we should see the icon. Yep, there's the icon file has been created. And the medium-sized file as well. So it all happens so fast. But if you run it all locally, what you can do with the emulators, you can set breakpoints and actually walk through and step and see how all this stuff kind of comes together. But pretty amazing stuff. And sometimes it happens so fast you don't even see it. So anyway, back to the code. So that's the backend API as well as the function, which is nice and simple too. Again, it's real lightweight. The function itself is based on the queue triggering it. In fact, when an item enters the process photos queue, this task gets run, automatically deserializes that little bit of JSON into a rich object, which we have defined down here below. It automatically maps the Cosmos DB ID for that same job item, as well as blobs to read the large image. It creates output blobs for the medium and icon-sized images, and starts running the thing to crop it and resize it and all that good stuff and save the data back. So, I mean, this is it. I mean, the whole function's 100 or so lines. And that's just where I'm at right now. I just got that up and running last night. There's a chat bot as well on the back end. There is a mobile front or a website front end. I can probably run that real quick too. Yeah, set that as my start. I'm still running here. Let me shut it down real quick. Set this as my startup. Run the front end. We can see our front end jobs we got in the queue, which are completed, total services. And I'm just getting the mobile stuff installed. It's been a while since I had the iOS and Android toolkit, so I haven't got that working yet, but you can see that a full implementation of an iOS client as well as a Droid client. So, I mean, I couldn't write this faster than I could get it to you and demo it. So really, really good stuff. The benefits of this, working with a really simple domain model that's got a fairly complete set of user stories around it. You can see the wide array of services that are used in it. The instructions provide how to do it both inside of Visual Studio or in VS Code if you prefer that method and that style of development. I'm still a big fat IDE guy myself, but I know a lot of people love code. There are full walkthroughs of each part of this implementation in the documentation, right in the GitHub repo. You can run it locally in your emulators or deploy it and run it in the cloud or any combination of the two. It has implementation using the native services as well as containerized versions of quite a few. The web API can be containerized. Some of the other, the functions and some of the other services can also be containerized if you're into Kubernetes and orchestration, including DevOps instructions in both pathways. And it's a great way. If you've not messed with Azure, it is absolutely the best way, I think, to learn it. We had nothing like this 8 or 10 years ago when we were just getting started with Azure. And if you are familiar with Azure, it's a great way to get tuned up on the parts that you haven't used in a while. I will tell you, the instructions are a year or so old, so some of the areas of the screens in the Azure portal have moved around. So for me, it was a great, couple of days spinning around, just like, okay, go get the cloud queue, spin up, go get the blob spin up, go get Cosmos spin up, set your keys in your configuration, and just having to learn where those have moved in the latest iteration of the tooling has been good for me. So good stuff all in all. So I encourage you to check it out. You can fork the repo on GitHub, customize it, make it your own. The guided walkthroughs are awesome. Extend it. It's nothing like having a nice little playground with a small domain to try out other parts of Azure that you haven't used. And definitely hit me up if you're trying it out and using it and you like it. And we will be doing a much deeper dive in a couple of weeks when the rest of my team have a chance to dig in and pick the bits apart and extend it with their own ideas. And with that, I will hand it back to John. Thanks so much, guys.
Thanks, Clint. That was cool.
It's pretty neat.
Could you throw that information in the chat as well?
I sure will. Yeah.
Cool. And I'm assuming the sign-up's pretty easy to attend.
Yep, it's just an Eventbrite. Yeah.
Cool. All right, Scott, are you ready?
I think so.
Okay. All right, so I'm going to just kind of introduce you as, I see that your title is the Director of Program Management for the .NET Platform, and there was a bunch of other things after that. So I just put and more. So would it be safe to say that you're the top guy driving, let's just, at least on the delivery side of .NET? I'm sure there's a lot of people involved in innovation, whatnot, but is that a little bit too bold to say?
Yeah, I think it's the right thing. I'm in the top leadership of .NET, so it's myself and John Cunningham. He's my engineering peer. He and I are kind of the two big bosses on top of .NET. But obviously I can't take credit for all the things that .NET does. We have a bunch of amazing people. I'm sure plenty of people on this call have met via Twitter or some of the videos and stuff that we've done. My team's about 65 people. If you just for an idea of how big .NET is.
Wow.
Engineering wise, we have a couple hundred, so it's a pretty big project.
Well, great. Well, I'm going to turn it over to you, and we're anxious to hear more about .NET 5 and 6. And Scott Spradlin and I will be monitoring questions in the chat. So if something comes up that seems like it's in reference to what you're talking about at the moment, we might chime in and say something, or someone else might chime in. Otherwise, we might have more of a Q&A at the end.
Yeah, I'm good for Q&A at the end or in the middle as well. So don't be shy. If you have a question while I'm showing something, feel free to ask, and just I'd appreciate if you would interrupt me and let me know, because if I'm looking at my screen, I'm not going to see the chat going through. And I'm going to try something crazy here. I'm actually my camera's on my really good PC, and my laptop is where all this kind of stuff's on. So I'm going to hopefully be able to share my desktop from this other machine and still be on my camera over here. So let's try this real quick. And if that comes through, then we're in good shape. Good.
Okay. Well,
amazing.
I'm gonna go and mute myself, and it's all yours.
Azure sitting here.
All yours, Scott.
So, thanks for the introduction. Thanks for having me. As I mentioned before, I'll give you some background on myself. I joined Microsoft around 2007. I was actually a Turbo Pascal programmer, followed by a C++ programmer, did a little bit of Java, and then I found .NET actually right around when it first came out. Then I went and did consulting for a couple of years, and applied to Microsoft and landed the job. And Microsoft's been a lot of fun. I came into the ASP.NET team Then my whole team, we all moved to Azure in 2010 when Scott Guthrie, who was the leader of .NET, moved from driving .NET and Silverlight to driving Azure. And when he did, he took all web tech with him, and so we went off to Azure for many years, from 2010 to 2016. A lot of what we call .NET Core today originated from some of the work that the ASP.NET team did over in Azure. And we came back into developer division. That's where Visual Studio and VS Code and .NET are built in 2016. And so it's kind of funny. One of our themes in .NET is unification. And we unified the teams. Now we're unifying the products. I saw the Turbo Pascal for the win. For folks that don't know, Anders Halsberg, who is the creator of .NET and C#, he was also the author of Turbo Pascal. It was very weird that I did a startup, and Delphi as well. So he was Turbo Pascal, Borland Pascal, Delphi, and then I was working at a startup in Southern California, and our startup was bought by Borland, and it was very weird that shortly after that we were bought by Borland, both Anders went to Microsoft, and then I followed a few years later, and so it was crazy. We just shipped .NET 5 back around the second week of November. And this is just a small segment of stuff that we did in .NET 5. There's single file applications. We have in .NET 3.1 as well, but they're much better in .NET 5. And they'll get much better again in .NET 6. At the same time, we want to make our container images smaller. So we're, microservices, Docker, Kubernetes, containers is a big thing. A whole ton of work we did in web and cloud. Desktop is very interesting. Desktop is still super popular. When we did .NET Conf, that was our launch event in November. The biggest feedback was that people wanted more desktop, and we actually have a mini .NET Conf at the end of February all around desktop. And I'll show a little bit of the desktop stuff. We have Windows ARM64 support, so that's a new platform that we support in .NET 5. So if you have a Surface Pro X, and of course, I think you'll expect to see a lot more ARM stuff from us in the future. If you look at the Apple M1 ARM chips, you can see the whole industry kind of going that direction. And so in .NET 6 from us, what you'll see us have WinForms and WPF running on ARM64. So basically all of the .NET workloads will support ARM64. We're always making perf improvements. For folks that were on the call early, I was saying you should always stay on the latest .NET because each of them gets considerably faster. And of course, we have lots of new features in C#, F#, and so on. This slide's kind of funny because it's out of date and it was only built 6 to 8 weeks ago. We have about 2.2 million .NET Core developers today, which is the ARM64 support will include WPF if that's what the question was. We have about 2.2 million .NET Core developers today, which is, to me, is amazing because we really launched this thing around March of 2017. So we're coming on this March will be at our 4th year anniversary of shipping a .NET Core. And to grow so many developers in such a short period of time is kind of crazy. Stack Overflow does a developer survey every year. And for both, we were the #1 most loved framework in 2019 and 2020. Super happy about that. We open sourced super late, but even though we were late, we are one of the top 30 most active projects in GitHub. And so happy about that. We open sourced in 2014, so we've only been open source for about 7 years. We're the top 5 language on GitHub. And then, of course, if you followed any things we've been doing the last couple of years, performance has been a huge piece of .NET, and especially .NET Core. And we're #1 on the plain text benchmark, and you're going to see we improved on all the benchmarks across the board. And then on our website, if you download .NET, you get a survey, and of the people that take the survey, a lot of those folks are students, which means new young people are coming into the platform, which makes us happy. If you want to think about .NET all up, we have over 5 million developers. I think it's 5.2 now. And we can only track developers that are using a Visual Studio product. And to give you an idea, we estimate that maybe Java's around $9 million. 9 million customers. And so and I expect Java to be bigger than us because they've been around longer, a lot longer. And so we think this is actually a pretty amazing achievement. I know what this was in 2016. We've grown a lot. As I mentioned earlier, desktop is super popular. We've had over 200,000 developers migrate their desktop applications to .NET Core, which I'm very happy about. I'll talk a little bit more about that in the future. To give you an idea of how much growth we have in .NET, we were getting in September and October, we added about 230,000 people a month. Brand new developers we've never seen in our telemetry before. So that's 500,000 developers in 2 months. So that kind of gives you the idea that we're doing pretty good here. We added support for Linux, back in 2017 with the first release of .NET Core. And we can see about 2 million of our customers actually publishing Linux assets, which is great. I should say publishes per month, not customers. But still, we're happy to see the usage of the Linux stack. One of the cool things about .NET is there's both great open source tech and there's some great closed source tech as well. And so this is just a list of all the partners out there that have supported .NET 5 on launch day. DevExpress, Infragistics, Telerik, Grape City, JQ Widgets, Radzin, and Syncfusion. Many of these have Blazor support, and many of these have WinForms and WPF support, which I'll show in a second. At the same time, it's hard just to talk about the closed source people when there's plenty of open source people as well. And I really highlight here, a lot of this is Blazor. The reason that, like, you see the top 3, 4, 5, 6, 7, there's 7 Blazors there. There's some on the other column as well. I'm calling them out because Blazor is a new brand new .NET technology. We have over, am I supposed to say? I'm going to say we have over 100,000 Blazor developers in under about 10 months. So 0 to 100,000 in about 10 months. And part of that's because the rich control ecosystem from the vendors and the support from the community as well. So Blazor has an amazing community around it, and so it's one of the strongest parts of .NET in the OSS world. I mentioned the Tech and Power benchmarks. This is showing, this is an older version. This is round 19 of ASP.NET Core 3.1. And this is a benchmark that Red Hat, we ship .NET in Red Hat, if you didn't know that, Red Hat Linux. And the Red Hat folks had modified one of our benchmarks. And so this is showing us being #1 on the Red Hat flavor of the benchmark, where they tweaked it a little bit. With .NET 5, we took all of these numbers and cranked them way up again. So if I go back there, you look and see we're at 7.3 million requests on plain text. With .NET 5, we're 11.7 million. So there's a couple million more there. Plain text is not the best benchmark in the world because it's not kind of real world. But we also wanted to make sure that we had massive improvements in what we call the real world benchmarks. And so you can see JSON. This is where you have an API that returns some JSON. That serialization, we improved the performance of that by 42%. So we're at 1.2 million requests a second, which is still an insane number. And then Fortunes, which is a benchmark that serves HTML. It makes database calls. It does this is the real world benchmark. And you can see even that one, we gained 20%. So if you look here, 20, 42, 38% year over year improvements. And once again, I expect .NET 6 to take all these numbers up again. So our hope is that, if you're a .NET developer, you realize there's no cheaper way to run a cloud app than running it on .NET. On top of that, there's even more. You can see here that we're trying to make sure that Linux is awesome, and so we've optimized our socket performance on Linux by 30%. This is just the JSON serializer by itself, not the actual benchmark. 19% over .NET Core 3.1. If you do large collections and arrays, 3 times faster, zero alloc, which means the garbage collector doesn't kick in. And then gRPC, which is kind of the modern replacement for something like WCF. It's modern because it supports all technologies. It's not limited to .NET only. And if you look at this benchmark, which this is a public benchmark, so we don't run it ourselves. We do in our lab, but this is the public version of it. And you can see we're faster than Java, we're faster than C++, we're faster than Go. This was run in October before we actually RTM'd. We believe that we're actually faster than Rust now as well. And once again, this just shows you that even using modern protocol technologies like gRPC, writing on the client or the server in .NET is going to get you the best performance. So let's jump and talk about Windows desktop development for just a second, because it was one of the big areas we got a lot of feedback for at .NET Conf last November. So what we've done is we finished the work of adding all of our built-in controls to WinForms and WPF designers. They're all there. We added ClickOnce support back to .NET 5. We had hoped that we were going to replace ClickOnce with MSIX, but it never has got the features and capabilities that our customers have asked for. So we brought ClickOnce back. And finally, we're now starting to see the third-party controls show up in the designer as well for WinForms. They already show up in the designers for WPF. So we're getting back to that parity with .NET Framework. The only thing missing in the desktop space is the data source dialogues are still not hooked up, and hopefully you'll see those hook up sometime this year. And why would you move your WinForm and WPF app to .NET Core or .NET 5? Well, first off, you get some cool capabilities. You can make single exes. This is, you don't require a version of .NET on the machine. You basically compile .NET and your app together into a single exe file. You copy that around and you're good to go. You don't need any .NET Framework on the machine or .NET Core on the machine. You can actually run these applications with no .NET on the machine at all. You can get all those perf improvements across the stack. And then we're taking some of the modern controls that are brand new, and I'll do a demo of this. You're all aware of Edge, I assume. We now take the web view from Edge and we make it available as a control. And so this is a great way to modernize a WinForm or WPF app to use a modern browser, not the old IE-based one that was built in before. And so let me just do a quick thing around this. This is an app that I built for that .NET Conf, and I call this a Goo Hoo Ha. And if you know all the Scotts at Microsoft, GU is Scott Guthrie. He's the big boss that runs Azure and Developer Division and AI. HU is Hunter, that's me. And then there's Ha, that is Scott Hanselman. And so, it's kind of the three big Scotts of .NET. And I thought it'd be fun to build a funny app to show off some of the capabilities that we have in WinForms in .NET Core or .NET 5. So let me open up the designer. This was actually buggy in November, and I'm hoping it's not as buggy as it was back then. We are working to make this better. One of the challenges, just to let you know, the designer is actually a interesting challenge, because I'm showing you a WinForm application, but it's running on .NET Core, but Visual Studio is written in .NET Framework. So we actually have to host this process outside of VS so it can actually rely on .NET Core. So we host another exe, and then we blit that window into the UI here, and so it's kind of fake. But here it is with the web view. That's the new web view control that we have. We just shipped in November as well, and so I can run this. And the web view control, by the way, works on .NET Framework as well. It works in all the tech. And so this lets me actually pop up a very modern browser using all the latest web tech. It's using the same engine that Chrome uses. It's based on Chromium. And so it's going to do all the things you expect. You get a modern browser. Now that's cool. But let's do a little bit more here. I'm going to drop this down and we'll have choose your Scott. And this is something new as well. As I mentioned before, we're starting to have, for the first time, third-party components show up in the designer. And so this is Teleric's control suite showing up in the designer. And if I look over here, all you got to do is basically reference their NuGet package right there. And that's all you have to do for it to show up in the designer. So once you reference their NuGet package, things just show up in the designer. And so I'll grab a rad drop-down list, stick it up here. And I think I need to rename this thing to the I think this is the Scott drop-down list. Save that. Close that out. And then we can show some cool stuff here. So let's make that go away. And so here I am in my form, and you can see what I do is I just create a bunch of Scots with their Twitter accounts. And then let's data bind that to the control. Let's do a build. Hopefully the world runs, and I can run the application. And now I can choose which Scots that I want. And it kind of does what you expect, but it's showing the new WebView 2 control that we have, and it shows that I can use third-party components inside of the designer for WinForms. So we're trying to bring all those capabilities back. Now let me show a C#9 feature real quick. We all have code like this. Here's a class. All it is a bunch of properties and a constructor that takes the properties. This is, a lot of code. I'm sure you folks all have probably files full of this stuff. So what do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's like 10 or 11 lines of code there. Well, one of the cool features we have in C#9 is something we call records. So what I'm going to do is I'm going to comment all that out. And this is a simple class. And I'm just going to write this instead. And so notice here that all I do is I say public, I replace class with record, and I just write the constructor. That's it. Writing the constructor is enough. From the constructor, we infer that you need a property called name with a value of string. You need a property called Twitter URI with a type of URI. And so this one line of code is the equivalent of this 11 lines of code. If we build it, should just build, should just run, works exactly the same way. And this is an example of the things I like to think that we're trying to do in C#, where we're trying to take places where you write a lot of verbose text and simplify them down into much less text. And as I said, if you're like me and you built a bunch of databases in the past, I can do this and reduce the amount of code considerably. So let me show one final thing on the WinForm Designer application, and I'm going to right-click and do publish. And this is glitchy, meaning that you have to select folder. We want to fix this in the future. If I select folder, then my favorite friend ClickOnce will show up, and I can say publish that, and I can just kind of go through and basically build a ClickOnce installer just like you would have expected in the past. Let's say, and I love, let's date ourselves from a CD, DVD, or USB drive. Yeah, no. There's all your stuff. But this, once again, is listening to feedback from you, the customer, to let us basically build an installer in. You can have your app on a URI, and then every time a customer launches the app, it'll have a chance to actually auto-update itself. And so that's some of the stuff that we're doing in the desktop space. Hold on 1 second here. Okay. Next thing, mobile development. It was funny. We were just showing a second ago, that crazy Azure application that had an iOS and an Android front end. We've done a lot of work in the Xamarin space, and I'll talk more about Xamarin later. I didn't do a demo today, but I'll talk more about it at the end of the talk. We did release what we call Xamarin Forms 5 in December, with a bunch of new tech for making beautiful looking applications with new brushes, shapes, and paths. We've improved the XAML experience in VS. For XAML, I think of things like that's the WPF designer or the Xamarin Forms designer. We actually made those things use the exact same tech. So they used to be two separate designers. We've actually merged all those things together. They're the same tech. And so now we make an improvement on one side, you get it on both sides. Another cool feature that we have is something called Hot Reload. And you're going to see in .NET 6 and VS vNext, you're going to see us take the Hot Reload concept and apply it across all of the .NET workloads. And if you don't know what Hot Reload is, Hot Reload means that when you're designing an app, this is especially important for mobile devices, because every time you stop the app and rerun it, you have to copy it to a mobile device or an emulator. That's kind of slow. With hot reload, you can change the XAML, press save, and the device will update immediately within sub 1 second. You can also modify the C# and press save, and the app will modify very quickly. We do that by only sending the diff of the code across the wire to the emulator or device, which makes that start very fast. And then the last bullet is probably my favorite bullet. I'm not demoing it today, but it would have been great for that demo that we had before me. I can take an iPhone and plug it into my Windows PC, and as soon as I do that, it will show up as a target inside of Visual Studio. I don't have a Mac here. I don't have to have anything. I don't have to even have a paid Apple account. I can basically, if I have a free Apple developer account and I have iTunes installed, all I have to do is plug my iPhone in or my iPad in. It will show up, and I can control F5 and F5 directly to it from Xamarin Forms, which I think is amazing. It's our goal here is to make the inner loop faster. That's the amount of time for you to develop, and no longer is it required for you to install emulators or Macs or put weird crap on your phone. It just works, and so it's my favorite feature. And you're going to see all this get a lot better in .NET 6 as we move all the Xamarin tech directly into .NET 6. This is kind of cool. We talked about this at .NET Conf. The Oscars, the academy that runs the Oscars, their entire app is built in .NET, Visual Studio, Azure, Xamarin, and it's pretty cool that they're running their entire thing. It's the way that people vote on the movies that win the Oscars is all they watch the videos and they vote the videos all via a .NET app. So let's talk about Visual Studio real quick. There's a bunch of cool stuff that happened. 16.8 is the version of Visual Studio we shipped in November that supports .NET 5. And of course, there's already a 16.9 preview as well. .NET 5 is included. Tons of .NET productivity improvements. There's a brand new Git experience, which I'm going to demo. Obviously, you heard me talking before. If you were in the first 20 or 30 that showed up, modern DevOps is super, super important. And so having an easier way for having our tool chains talk to Git is super important. If you're on the 16.8 GA or 16.9 preview, we have Linux debugging enabled. It does not require you to have Docker or anything installed. I'll show that as well. It's got that improved XAML experience I mentioned before, where we've actually taken the same XAML designer across WPF and Xamarin. And then finally, as I talk about DevOps, really the way you should be publishing your applications is something called GitHub Actions, where we actually build and publish your apps in the cloud using all that tech. And so let me show a couple of things here. So we launch a preview version of VS, and all I'm doing is I'm running the latest preview of whatever is publicly available. One of the things I always try to do when I talk to folks is, and I will show a single exe in a little bit, folks. I always try to show the what you can download. So this is just going to be 16.9 preview 3, same kind of public bits. And I have a Razor Page app here. It's not super exciting. And all it does is it writes right here. It writes the OS version out to the screen. So it's not that exciting. And it does exactly what you expect. If I run the application, it says that I'm running on Windows NT, which is what Windows reports, what you would expect. So if I come back over here, I can now drop this down. And this is something that's enabled if you have WSL 2 installed and you have 16.8. You're going to see this. There's my WSL 2. I'm going to select that. And just by doing that, I also want to be very clear. If I look down here in my list of stuff, there is no Docker running here. So I have no Docker running on my machine at all. I can control F5. And this is going to use a technology called the Windows Subsystem for Linux to let me run the app on Linux on my Windows machine. So no longer am I required to go and run this in a VM in the cloud or run Docker. I'm going to get an inner loop that's the ability to change something and update the screen, it's basically the same speed as I was before on Windows, except I'm on Linux. And so now I can easily, on a Windows machine, you see the starts really fast. I can develop on Linux. And it's full tilt. So if I come back over here and I place a breakpoint on the Razor page here, I will be able to run the debugger just like I did before. All my options are available. Debug, start without debugging. All the tech just works like you would expect. Now, let's take this app and let's do something to it. I want to add it to GitHub. So I'm going to say I want to create a GitHub repository. And there's my source code. It knows my GitHub account. I'll say web app Linux. Perfect. I'll make it private. And then at the end, it's going to push my code up to GitHub. So literally right click. There we go. Stuff's going on. Everything's up to date. If I go back to GitHub, refresh my page here, there's my web app Linux. Here's all my files. And so you can see how easy it is to get an application running up in the cloud. Now, let's take that a step further. Let's go back over here, and I'm going to right-click publish. I know people say don't ever right-click publish, but when I do this, and we'll click. Let's go to Azure. Let's click next. Let's publish this to Linux. Let's click next. And I've already got a machine running in the cloud for me. There's my web app Linux. Let's click next. And this is something brand new. I can choose to either publish, like we did before, we create a publish profile, and then every time you change your source code, you can right click and publish it up to the cloud. Or now we can automatically create a GitHub action for you. And GitHub Actions is how we do CI/CD in GitHub. And so I'll select that, and I'll click Finish. There we go. And so what that should do is that should actually, I'm going to have to make a commit here. And say add to, or actually add CI/CD. Commit that. Watch the magic happen here. Let's do a push. And once I initiate that push, now I already had a empty web app running in the cloud. But once I create that push, if I go back to my portal here, and I look at this thing, I can click on the Actions tab here, and look here. Build and deploy .NET Core app to Linux web app. There it is. I can click that. I can click the build, and now we can actually see in the cloud how what's going on is it's going to go and install .NET Core into the proper folders and stuff in my project. There it goes. Now it's going to run a build. There it goes. If I had tests, it would run the tests. Now it's going to go and deploy the app to Azure. And so now that I've made this change, anytime I go back to the app and I make a change, this action will kick off, and I'll have a full CI/CD workflow into the cloud. And this is the way we probably should do things, because it means if I'm in a team environment, any of us that are modifying the Git repo will cause a push to the cloud. And this tech supports all the things you might want. If you have a staging site and a production site, this will go to the staging site. And when you're done, you can decide that you're ready to go and make it go live to your production site. You can do what's called a swap. and we'll swap that up. But if you look here, this should have all completed. And it would go on to this guy. Here's that running. Let's just go make sure that everything's going on here. I think it's all good. And let's see if we have an app. There you go. Now I'm running on Linux in the cloud. So I was able to take my Windows machine, build an ASP.NET Core app, debug it and run it locally on Linux on my Windows machine, and then right-click and easily add it to GitHub. And then from there, I could right-click Publish and create a CI/CD action to build this and put it up in the cloud. And so I think that's a pretty awesome improvement we've had, you know, year over year with this technology. And you're going to see us continue to do more and more in this space. Let's shut that stuff out. And I'll come back over here. There's one more feature, but I'll show it in the Blazor section here. Now, web and cloud development, bunch of stuff here. You know, we shipped Blazor in .NET Core 3, and then we had an update last summer where we added WebAssembly support to it. And for folks that don't know, WebAssembly lets you actually run .NET in the browser. And now we have the kind of the third version of Blazor that ships in .NET 5. Obviously supports our Blazor server, which is the recommended way of building the most lightweight application you can. And then Blazor WebAssembly, which, because we can run .NET in the browser, lets you build disconnected offline applications, because the app, your C# is running in the browser, which means that the app doesn't need a network or anything else. We call these PWAs, where you can actually make a web app look like a desktop application. Now, we've done a whole bunch of improvements in Blazor WebAssembly. In the 3.1 timeframe, the WebAssembly only supported .NET Standard 2.0. Now the Blazor WebAssembly supports the .NET Core or .NET 5 core libraries. So all the libraries in .NET 5 are available. It's 3 times faster than it was in the previous release, done a bunch of optimizations. There's tons more we can do. And some of the coolest stuff is we support server-side pre-rendering. This means your app launches the fastest. I mean, we all get tired of going to some website and seeing it say, you know, it slowly loads. It also lets us cheat the server-side pre-rendering. We also support something called lazy loading dependencies, which means instead of trying to boot the whole app up at once, the app kind of only uses what it needs as you start hitting it. So we don't have to start the entire app. We only start what's necessary. We have what we call component virtualization. This lets you build a grid with like 5 million rows. We have CSS and JavaScript isolation. As you build components, they don't want to make sure your CSS and JavaScript don't bleed between things. And then obviously there's a huge growing ecosystem of third-party controls, both by commercial vendors and by open source people. And this is a cool company called Postage. They actually built an app very quickly with Azure and .NET and Blazor. And so they were a cool thing. So let's jump over here and let's do some Blazor. So let's go back to the start menu here, and I'll select a Blazor 5 application. And let's close that away. Okay. And so there's a couple things that I want to show off in the Blazor app. And the first one is, let's open up the app here. As I mentioned before, if you had a Blazor app in 3.1, the target framework would have been Net Standard 2.1, and that's because we basically a Blazor WebAssembly application runs on top of Mono. That's the same runtime that we run a Xamarin app on, either an iOS or Android Xamarin app. And Mono honestly has its own BCL. It's not the same code as we have in .NET Framework or .NET Core. But what we've done in .NET 5 is the Mono that we run a Blazor WebAssembly app on now uses the exact same core BCL that we use for the rest of .NET. And you're going to see the Xamarin Tech move to this in the .NET 6 wave. This just means you have more compatibility. The same exact code your server applications or your client applications have is being run for your server application. So I think it's cool that we're actually now targeting the right framework. Now, one of the challenges you have with Blazor is, let's go look over here. This is the startup of my app. Now, as I said, this is a Blazor WebAssembly app. This means the app runs in the browser. It doesn't require any client access. Well, there's a challenge there. Blazor WebAssembly runs inside of a sandbox inside your browser, which means it can't run all the .NET APIs. It can't write to the file system. You would not want your browser just randomly having apps running your file system. And so what we've done in this wave is we now have an analyzer that's built in. And if you write code like this would never work. You can't do a read line in a browser. And so notice now that I get a squiggle. And if I hover over this, it basically says this call is unsupported on browser. So we now have an analyzer that looks to see what code you're writing and will give you an error telling you if you are trying to use something that's not supported inside the browser. And so that's a nice improvement. Can't make that mistake. Next thing, let's run the app. Before I run the app, though, let's go down here. host.cshtml_host.cshtml is the main web page that makes up a Blazor app. Even though it's a single page application, it still has to have a default page. And this is it. And typically it's got some stuff that we inject at the very top of the page. And then it's got some stuff where we'll go and stick your main application. And that's right here, the component type. That says basically put the client app inside of here. And now notice the rendering mode, this is new in .NET 5, is called WebAssembly pre-rendered. And what this means, if I run this application, normally if you run a default Blazor application, you'll see a little spinner. Notice that page came up very quickly. No matter, I wish that would go away. There it goes. Normally on a single page application or even a Blazor app, the default launch will give you a spinner while we're kind of waiting. It'll say, waiting, loading. This app, I'm pressing F5 as many times as I want. It will never say that, because what we did is we actually rendered this HTML on the server the first time. And so the WebAssembly doesn't have to kick in. None of the rest of .NET has to kick in. And the goal here is to make your single page application feel super, super fast. Now, while I'm here, let's show another cool feature. Let's go back to Visual Studio. And let's jump up into the index page. And I could say, hello, St. Louis. And I'm just going to press save. And I'll switch back to the browser. Notice I didn't rerun the application. This is a little chunky. And watch it not work now that I have you here. Come on, Tech, you can do it. This is making me sad. What is supposed to happen here is the page is supposed to refresh by itself. So I've pressed F5, but we have a new feature for all ASP.NET web applications where if you make a change on the server, it should just update the client automatically. You can see it did rebuild automatically when I press save. And now it works. I'll press this. I'll do again. I'll come over here. And now watch it not work again. There it goes. And so, but notice it did take a couple of seconds. So one of the big areas we're going to improve on in .NET 6 is making what I call this. You make a change in the app, you alt tab to the browser. How fast does that happen? We're going to make that a lot faster. Now this feature, let's see if I can actually find this feature. Welcome to hell. What I went to is I went to Tools Options, and I opened up the Projects and Solutions node, and notice that I have this new feature called Auto Build and Refresh Browser after saving changes. This works for all applications, whether it's MVC, whether it's Razor Pages, whether it's Blazor, and by enabling this, it's not on by default. I hope to make it on by default in the future. You make a change to your code, alt tab your browser, it'll just live refresh. So that is that. Now, let's look at another one. On my main page as well, notice I have this component that's put here. Now, in the past, if you're using Blazor 3.1, you would have to come over to this host HTML file here, CSHTML file, and you would have to include any of your CSS or any of your JavaScript somewhere up here for them to show up. Now, what's cool is with .NET 5, what I can do is I've got this class library here, Razor class library, and inside of it, I've got this simple component. This Blazor component is defined, and we'll use a strong attribute here. And now what's cool is notice that nested underneath that, using the same syntax, myComponent.razor.css is the CSS that we associate with this. This is isolated, and what's cool is it ships with the component. And what this does, obviously, it's going to put a background on here as well, which means I'm going to have an image here as well. And so we've got images and CSS. All that stuff comes now with the component. Nothing has to be, blasted into your project. And I should be able to come back over here and just uncomment this. Dare I try saving it? It refreshes. There's that component. It's got the cool background. This is a new feature in the component tech, which makes it even easier to include your images, your CSS, your JavaScript. And we do all the tech to make sure it doesn't overlap with any similarly named JavaScript or CSS. And the last thing that I think is really cool in the Blazor space to show is this. One of the biggest challenges we all have with applications, whether it's a desktop app or a browser app, is like one of my big customers on the East Coast, a big financial firm. They told me that we're a grid company. We have lots of grids, and so how do we make ASP.NET applications that can have lots of data? And so if I go look, not there, but if I go look at my pages and I go to my fetch data page. What I've got to do here, normally on a default application, we would have a for loop that would loop over some data and present it. In this particular case, I replace that for loop with a virtualize tag helper, and I give it a method to get the data, and then I tell it how big each row of data is. Basically, that's 50 pixels tall. Now, notice up here, I say the next 100,000 days. So what I'm going to do here is create enough weather for 100,000 days. So my get weather range, it's going to take one of these types. And if I look at that, I did not mean to hit that. Stop. If I hit that, you can see it's got a start index, it's got a count. It's got a couple parameters. You're just pasting some data back and forth. But then what I can do is basically tell it I want 100,000 days of data. We can write to the console so you can see what's going on as you run the app in the debugger. And it returns basically that data. Now what's cool, if I go back to my app here and I go to the fetch data page, it's hailing outside here, folks. Getting some of your weather. Let's run this. Let's go to fetch data. There's that data showing up. If I go to my browser tools and I go to network, that go away, and I grab this, you'll see all the requests come in. So basically what we're doing is instead of trying to go grab all the data at once, every time you move the scroll bar, we make a request for the chunk of data that's required for that view of the screen. So you can see there's the data there. You can move this away, and you can see kind of how that kind of works. And so this allows you to basically have web pages that have unlimited amounts of data that just work, unlimited. So this is, I think, a pretty cool feature in Blazor. Let's close that out. Next is cloud, cloud native investments. Obviously, the cloud is super important to us, and making sure that .NET is, at the tip of the technology is important. So we've done a lot of work. REST APIs, we've had Web API and .NET for a long time, but we've done a lot of work. One is something called Open API that was mentioned as well in the crazy Azure demo before. That particular app already had been enabled for Open API. Now, when you do a file new, you have an option to do Open API for any Web API. We have something called the API REPL. This is an easy way to test your APIs, and I'll do a demo of that. We have client generation. I think this is the most important thing is as I talk to WCF customers, what do you like the most about WCF? Well, I write the server, and then I just right click on it and say, make me a client, and it makes it very easy to call. We do the same thing for a REST API. As long as you have Open API enabled, you can right click and we'll generate the client for you dynamically. And we now have a capability too, where not only can you publish your API to Azure, but you can also publish it to API Management, which is a way of controlling access or rate limiting or doing or getting logging for your APIs. And so we've made that integration even better. And then we have gRPC. This is for if you're really a WCF style person, you like contracts, you like rich type safe APIs, we have that built in. And once again, we can generate the client. The question, no SOAP support? No. There is a great SOAP project for .NET Core though. So there, if you're looking for SOAP, there is an open source project that provides great SOAP support. And we also have a port of WCF that we've done as well. It's kind of an open source project, and we use it for some internal projects at Microsoft. So if you really want your SOAP, you can go get the SOAP there. You might ask, why no SOAP? REST is supported by all devices. And so that's kind of, it's the common denominator. And the gRPC is cool tech, and REST is also supported by all frameworks and languages. gRPC gives you the same kinds of type safe API calls as you got in WCF, but you get those with the ability to use different languages as well. So both of these techs are cross-language, and we both will generate the clients and servers for both of them, and obviously awesome performance. And then we have smaller, faster microservices, single file apps, top level programs. I'll do a demo of both of those in a second. We have Project Tye, which lets you easily build and deploy microservices to something like Kubernetes. Already showed the cross-platform development with WSL. And we're building a reverse proxy as well as a way for us to benchmark and make .NET faster and faster. Also, this is kind of cool. If you've been following us for a long time, .NET Core 3.1 took half a year to get into app service. We had .NET 5 in app service on day 0. And Azure Functions is the next thing we're going to work on getting into day 0. Okay, so let's do a couple of things here. Let's go back into my VS. And let's make a new project. And what I will do is I will build a, wow, this is crazy. Let's build a web application. Make a name that will not be taken on my machine. And I'm going to select .NET Core 5. I'll select Web API. And then there's this new checkbox, which is on by default, which is enable Open API support. That enables that technology. All that client generation stuff requires this. I'll click create. You used to be able to do this yourself by adding NuGet packages, writing some code. And we really don't want you to have to do that anymore. And so here I am in my default project. Just finished. And so just to show, I mentioned this before, if I go look at my packages, you're going to see the Swashbuckle is now hooked up by default. we've actually hooked up all the code to make it run by default, and so you're ready to go. And so if I can control flag this API, now I get to a kind of a mode like this where I land in the same thing that he was showing in that Azure demo before. Here's my API. I can go and click the get. I can click try it out. I can click execute, and you'll see it returns the results of my API. I can tweak some of the parameters and stuff here if I wanted to. And that's just a cool aspect of the tech. Makes it easier to build and debug your APIs. But it was kind of cumbersome. I had to go click a bunch of times to actually make that happen. So let's cancel that out. It also gives me a link to this. This is my Swagger. This is my description of my API. And I can take this and I can right click and I can say save as and swagger.json, save that like that. And that enables a bunch of other cool tech. But before we do that, let's go back to, let's keep closing out here. Dare you send me out of my portal. Let's go back to the app. And what I'm going to do is I'm going to drop down this list again. And I'm going to go to web browser. And we got all the regular suspects, Edge, Edge Dev, IE, and some Chrome. But I'm going to select the HTTP REPL. And when I do that, now if I control F5 this application, it just brings me to this command line interface. And from here, I can do things like dir. Hey, there's a weather forecast. I can go into weather forecast. And now that I'm inside a weather forecast, I can just type get. That'll return the data. And the reason this is a little simpler than that web interface is because here, imagine I just alt tab over here, I change my code, I come back over here, I run get, or I set a breakpoint over here, I come back over here and I say get. Super simple. The idea is to make this inner loop faster and better than ever. Today, the REPL is actually what's called a global tool. So I can, it's just a command line tool. We are going to make the installation of it easier in the future, so you don't have to do a couple manual steps to get that running. Put that back. I'll show one more thing here. I'm not going to really do it all the way. But I want to just show the idea here. I can come over here and I could say, well, let's do this. Let's right click on my solution. Let's add another project. Let's go and select a .NET Core console app. And I'll call it my client. That folder is fine. And you've all done this. Now I've got my my API, I've got my client. But what's new is, let the circle of patients go away. I can right click on my client, I can do add, and there's now the service reference. And you can see I can either add an open API or a gRPC. I'll say do an open API. It wants either a file or a URL. Remember, we saved that Swagger to my download folder. I can select that. And I'll just skip the rest of the stuff here. And what we're going to do is we're going to add a NuGet package to your project. We're going to go do some magic for you. Notice that my client shows up here. Let's see if this has actually been fixed. You generated code. And now you can see the 266 lines of code we generated that basically lets me new up the API and call it. So it making it just like using DevCF. Super, super simple. I'm not going to go there because I'm going to try to finish in 15 minutes. Sure, save. And that's APIs. Now let's talk about microservices for a second. And I saw lots of interest in the chat about single exe applications. So let me do this. I've got a 5.0 microservice. I'll launch another VS. There is that microservice. Let's launch another one of these. Go away. This is our 3.1 application. Microservice 5, microservice 3.1. And let's highlight a few of the differences, and we'll show a few more C# features here as well. So this is the kind of the smallest API you can build in .NET today. And this is something you'll see us invest in more in 6.0 as well, is making these APIs, less code API. If you want to write a full web API, great. If you don't want to write it that much code, we'll work for you there as well. So we're going to make it easier just to write, simple APIs without having to have a controller. But you can see I built a host for the web. I then tell it I want an app. The app's just going to run a method, which means anytime the app is hit, it's going to return this response. So this is there's a couple things here. There's 23 lines of code here. There's this public class program. There's this public static void main. Just a bunch of unnecessary goop in many ways. And so let's go look at the same project. Let's just first, it does run. Oh, it's mad at me, Scott. So we have to go fix this at some point is let's go fix the browser back to Edge. There we go. That's exactly what you would expect. Now let's go look at the same project in 5. Now in 5, I'm going to use what's called a top-level program. And so notice that instead of being 24 lines of code, now was it 24? 23 lines of code, it's now 16 lines of code. And the stuff that's really missing here is there's no class program and there's no static void main. Why not just be able to write C#? So I just open a file and I start the application. And so that's just a thing we're trying to do, where once again, using C# to limit the amount of junk you have to write. And obviously the app's going to do exactly the same thing. Now, people on the chat earlier I saw talking about, and this works for all apps. You can do this in a WinForm app. In fact, that WinForm app I showed earlier used the same technique. I just didn't show you the file. But another cool aspect of this is, and things that people aren't aware of, is if I go on an API like this and I right click and I do publish. Now I'm not going to publish to Azure. I could, but I'm just going to publish locally to a folder. And I've already set this up. Notice that I can come over here, and what I want to do here is I'm going to click this. This edit. And when I do, there's a bunch of settings you probably have not even seen before, even though they exist today. And what these are is, number 1, I can choose to have an app be either framework dependent, which means there's a .NET framework on the machine, a .NET 5 or a .NET Core on the machine, or I can make it self-contained. Self-contained means what we'll do is we'll take your app and .NET and shove them all in the same folder. Great. That's kind of nice. I can then copy that folder anywhere. It'll work on any machine. But if I open this up, I got a couple more options you might not have seen before. One is produce single file. This tells us, don't just give us a folder full of junk. Go take the .NET and the app and compile them into a single exe. And then that would make a big exe, by the way, because that would be like 50, 60 megs of .NET Core, .NET 5, plus your application. And then there's this other option, which is more experimental at this point, which is trim unused assemblies. And in this case, what we do is we look at your app and go, anything you're not using, we're going to toss away. And so let's take a look at the output of this. And just to be faster on time, I will just go and open this in here. Ben, release, NetCore 3.1, publish, and there you go. Look here. This is my 3.1 application, and it produced a 45 meg exe. And just to prove that things still are real, if I run the exe, please process 45 megs of stuff. There you go. The app runs and loads. Now, let's go let's do that same process on the 5.0 application. Open folder in File Explorer, Let's go into bin, release, net5, publish. Now that exe is 21 megs. And so if you look at these side by side, and we scroll this over here, 45 to 21. So cut that more than half. If I go over here and run the 21 megger, notice it launched a lot faster as well. 21 megs of stuff, less to go. And this is just showing this commitment that we have to go keep trying to make .NET apps smaller and smaller and smaller, like some of our competitors. If I go back, and I'll just do it from the other one because I already had the window up. There's also, you have another option here as well. And that option is, I can also choose enable ready to run compilation. This will make your app a little bigger, but what it does is it means we've pre-compiled the app, which means it doesn't have to JIT, which means this will make the startup time faster, app a little bigger, but you can see where we're going here. And so this is an area you'll see us to continue to invest across the product as we move forward. And let's go back to slides, and I'll do one more of these things. Project Tye, this is an experiment that we're now just trying to figure out how we're going to ship this in .NET 6. And it tries to solve a couple of problems. Here is an example of a real world application. I've got my front end web application, could be Blazor, could be MVC, could be a WinForm app. And it's got 3 services that it's going to call. Somehow it's got to find the IP addresses and ports of all 3 of those services. And notice some of the services have to find each other as well. That's a problem. Tye will solve this. The next thing is those services might have dependencies. You know, you've all played the game where you have to install a SQL Server or some other thing on your machine to get some app to run, you know, Android emulator, whatever. We want to be able to bring some of these things to your machine without you having to actually install something. We'd rather bring them as a container. But that means you have to write Docker files. Don't want you to write Docker files. So we want to solve that. Next is I want you to be able to run locally using containers. If you're going to run in the cloud with containers, you might want to run locally with containers. And so we need to make that work pretty easy as well. And then finally, once you start running a multi-project application, well, how do you know if both the services are running or all 3 of the services are running? How do you look at all that? It's very hard. Today you would have to attach VS to whatever instance you care about. So we're going to give you a dashboard. And then finally, we want to take all those apps and be able to easily publish them up to Kubernetes. In this case, I'm showing Azure Kubernetes Service, but this would work with Amazon, Google, whatever. The tech doesn't matter. Kubernetes is Kubernetes. And this is Project Tye. And so I'll do a quick demo of that, and we'll try to close out then. So here is an app I've got. It's got a front end app and a back end app. And, you know, I could do the lazy way. I could do this kind of thing, .NET run. And that's my front end. I could do a .NET run. On my back end, if I'm inside of Visual Studio, I could easily say, you know, start both projects at the same time. But you're going to notice that once both of these are running, let's go grab the port here and this, and I go back to my browser, and I will expect this to fail for the problem I just described. What's happening here is you can see it's getting a failure trying to call the endpoint. It's being refused. And that's because it doesn't know what the endpoint is. So let's stop that, close the tab, stop that, close the tab. And what I'm going to do here is I'm going to type a new command. Well, first off, before I do that, let's go into VS Code. And I'm showing this in VS Code because we don't have a full VS experience yet. We're not that far along. And let's go look at my startup.cs. What you're going to find here is you're going to find that what I did is, Hunter, I hard-coded a URI and a port. Well, that's not very smart. You might say, Scott, just put that in config. Well, I could, but still config's a mess too. And then once I publish it to the cloud, all that's going to change. So we don't want you to have to do that. And so to fix that, what I have to do today is I have to actually add a package. I don't want you to have to do that, but this is preview. And so in preview land, yep, do me a restore. I'm going to add this Tye.extensions.configuration. And what this is going to let me do is go back to my startup, and I'm going to comment out that hard-coded line. And now I'm just going to reference the backend by its name, configuration.getServiceURI backend. And what we'll do is we'll do all the magic to make sure the ports and stuff all hook up and you're good to go. And so that's, I added a package. I changed the line of code from being hard-coded to using a config file to just using a convention. And then I can come back over here and I can do something like Tye run. And what Tye run's going to do is it's going to look at my folders, it's going to find all the CS projects, and it's going to boot them both up at the same time. There you go. And it's going to give me a dashboard. I'm running a cool VS extension that I don't think we've actually shipped yet. That would actually let me see this. Maybe I won't show the extension. Here's the extension. There it goes. I can click it. It's going to open up a dashboard. This is a new concept. So here's my front-end web application, my back-end web application running. I can look at the logs for either one of these things. There's the logs. I can click the URI to launch the app. Now the app works correctly because of that mapping you just saw me make inside of the startup.cs. Now the front end can find the back end. We're good to go. So it's a much better experience. If I want to see the performance counters, they're available here as well. So we give you a bunch of new capabilities. Now that's great. Let's go a little bit further. So what I'm going to do now is I want to use a Redis cache. I want to add a Redis cache to my application, but I don't want you to have to go install Redis manually. By the way, Redis is Linux, so it's kind of hard to install manually. So what I would do is I would do Tye init, and that's going to create a new file. If I go back over here, get this Tye YAML, and this is basically what Tye figures out by itself. Notice it found the front end project, CS proj, the back end project, and now I can just go add whatever I want to this. So I can come over here and say, let's add a Redis. So we'll add that. And so in this case, instead of giving it a project, I'm going to give it an image. That's a container in the cloud, and I'll pass a few parameters to that image. Save that. And before we run this, let's go add a few more things here. I'm going to go to my CS project again, and I'm going to add the Stack Exchange Redis client, so I can use Redis in my project. Sure, restore. We'll go to my startup CS, and now that we have Stack Exchange, I'm going to dependency inject the Redis cache into my application. And once again, notice how simple this is. I don't worry about the connection string. I just say get connection string and give it the name of the actual cache. That's it. Nothing complicated there. And now if I go to my index.cs.html, I have this commented out. We have a tag helper in Blazor or Razor or MVC it's a cache tag. And so what I'm going to do here is let me just uncomment this. There we go. And what this cache says is distributed cache. We're going to call the cache weather, and we're going to say we want it to last for 5 seconds. Now, because Redis is going to run it in a container, I need to start Docker. Let me start Docker. This is a second to boot up here. You can see the whales starting. And I'm using, Windows Subsystem for Linux, the thing I was using to run on my Windows apps or my VS and be able to access on Linux. It also works really, really well for Docker. And so Docker is much faster. So now Docker is running. And I can come back over here. And let's type Tye run. And this time, it's going to find it says running Docker command. It went and saw that my Tye YAML file had a reference to Docker, or had a reference to a container, And so now it's going to boot up all the pieces that I need. Let's go back to the dashboard, refresh the dashboard. And now I've got my two apps and I've got my Redis cache. So that easy, that fast. I'm now running Redis. I didn't have to install it locally. It's running in a container. All the metrics and stuff. Let's go click the application. There's the application. If I press F5, only every 5 seconds does it refresh. That's kind of cool. I'll run it one more time before we run it in the cloud. Let's let this all go down. There we go. Tye run -- help. Now it could be that maybe notice there's this -- docker command. Tye run -- docker. What this does is tells us run everything in containers. I really want to simulate exactly what's going to happen when I run this in the real cloud. And so here it all comes up. If I go back to my dashboard, I do a final refresh. Now everything is container, container, container. Once again, app works just like it did before. And now for the final part of this, and what I didn't show you is, I've stopped and started this many times. Another command that's on the Tye run is -- watch. If I had done Tye run -- watch, I would have been able to just go make changes to the projects. And when I made a change, we automatically restart. But let's do Tye deploy -I. I want to put this thing in Azure. And so it needs a container registry. That's where my containers are going to go. So let's go back to our portal. Let's go to the dashboard. I'll go to my registry. I'll just grab that, paste that in. And now what we're going to do locally is we're going to build all those containers. We're going to upload those into my container registry running in Azure. It also detected that I'm using a Redis cache, and it says, "Hey, do you want to run that Redis cache in a container, or do you want to use the Azure service?" And in my case, I want to use the Azure service. Let's go back to the dashboard. Let's go to my Redis cache. Let's click access keys. We'll grab the connection string, paste that in. That tells it basically, when I said get Redis, it's going to go get that one in the cloud. I missed one thing. Let's do one more thing here. To actually have the app run in the cloud correctly, I need to have what's called an ingress server. So let's go back to this file here, and we'll go back to my notepad here. These are things that will make easier for you, because I don't want you to learn this stuff and write this stuff. That's why this is an experiment at this point. And I'll come up here and put an ingress server here. I'll save that. Let's go back to Tye deploy -I again. Sorry for missing that step. And we'll go back to the dashboard. Obviously, we'll cache these things for you in the future, so you don't have to redo these things. Actually, I kind of asked for it. I said interactive. It should keep the Redis, though. Front end, back end, Redis, published. There we go. This is a command that tells Kubernetes to go find me the port and the IP address of the ingress server. That's the public face of the website. Because this is the first time that I published it, it might take a couple seconds to get this done. We're going to make the Tye deploy command actually do this for you in the future. It'll actually kind of go into a watcher mode and watch for this. It'll come back at some point. While I'm waiting for that, I might go back to slides and come back over here. but it will come back. I will just let's go jump to finish the slides, and then we'll come back and I'll show you the app running in the cloud. Okay, so going forward, our vision all along is, we've got too many .NETs. We have .NET Framework, .NET Core, and Xamarin. And, our vision all up is to go and take these and over the 5 and 6 wave is to make this into a unified platform where there's one SDK for building all your projects, Xamarin, desktop, console, class library, ASP.NET. There's one BCL I mentioned before. The Blazor WebAssembly was using the same BCL as the rest of .NET Core and .NET 5. We'll move that over to Mono as well, or not, to Xamarin as well in the .NET 6 wave. And those command line tools, .NET Run, .NET Build, .NET New, we want those to work for all the project types. We want to have awesome cross-platform native UI. This would be through either Blazor running as a desktop application or .NET MAUI. That's the future of Xamarin running as that. We want to have awesome cross-platform web UI. This is, once again, Blazor again, Blazor Server or MVC or Web API. We want to have amazing cloud native. This is all the stuff around Project Tye, containers, Docker, whatever. We want to have, continuous improvements in the speed, size, diagnostics for our platform, more support for Azure. And we think that at the end of .NET 6, we're going to be back to where we were, I think, in 2002, where .NET was the best at building a ton of different app types. Obviously, we just shipped .NET 5 this past November. .NET 6, our LTS, will ship this November. And you'll see that, our plan is every year, every November, there's a new release. The quality of these releases is all the same, whether it's an LTS or not an LTS. It just means the support, how long it's supported will last longer. Obviously, .NET 5 is available now. Go out, try it, grab it. The new VS is available that supports it as well. Try and get that. And with that, thanks for joining. And you can also find me on Twitter as @CoolCSH. And let's go back and see if this ever decided to cooperate. There it goes. There's the IP address. Let's pull that in here. Let's go back to a browser. And there is that app running in Kubernetes, which is a complicated piece of tech, but you saw one deployment command, a simple configuration file, and I've got my app running with a service and multiple microservices up in the cloud. And so with that, I will stop sharing my second machine and hang around and answer a couple questions if I can.
Very cool, Scott. Yeah, if you have any questions, post them in the chat, and we'll go ahead and address them. One question I have, though, is when it comes to you touched on the performance and how, when it comes to .NET 5 comparing to like Go and, some of the backend languages, what would be some of your advice when it comes to different companies, tackling on the front end when it comes to Angular and React and trying to make that decision of what to invest in, and looking at Blazor, not so much server side, but Blazor client side. So
why did you skip Blazor server side?
Well, I don't want to skip it per se. When it comes to comparing the client end, Angular and React are really pure client end. And then when you have, that is definitely a benefit of Blazor where you could have server and client. I guess, yeah. How do you address that? I mean, is it?
Yeah, I was going to say one of the things that I think that that our .NET customers fall into is, Blazor WebAssembly, man, it's amazing. It runs C# in the browser. That's amazing. I should do all my apps in that. If you build an Angular app, a React app, a Vue app, a Blazor WebAssembly app, they're all going to come with some size, meaning that you're going to bring those JavaScript frameworks down to the client. In the case of a Blazor application, you're going to bring a Blazor WebAssembly application. You're going to bring a copy of whatever .NET you're using and your app down to the client. And so, on those apps, you could be, a meg or 2 or 3. One of our goals is to make sure that a Blazor WebAssembly app can be in the 1 meg or 1.5 meg footprint. But the apps are going to be large. Even React and Vue and Angular are going to create some bulk, even if you are running Webpack and some of the tool chains required to strip those things down a little bit. And so I think people discount Blazor Server. One of the cool things about Blazor is we don't care. It's designed so when you build components and you build your pages, they don't care if it's running in server mode or WebAssembly mode. So your code should be exactly the same for the most part across either of those. Blazor Server gives you a huge benefit that we don't have to crank any JavaScript down to the client for the most part. And so if you build a Blazor Server app and look at the page size, you're going to be 100 bytes or 200 bytes or 300 bytes. Versus if you build an Angular React Vue app, you're going to get a much bigger footprint than that. And so Blazor Server is going to be the best for light network access. It'll be better than any of the web frameworks that are out there, once again, because it's just going to be smaller. And what it does, if you don't know how it works, is when you make you touch something on the page, we send a command down a SignalR pipe to the server. We re-render the page on the server and we send the diff back. And so all you're doing is sending diffs over the network, which are typically very small. So it can be very lightweight, very high performance. And you're going to see us continue to do work to make the back end to that go. When it comes to the question of, do you do Blazor, Angular, React, Vue? There's no magic answer there. There's plenty of people that will like the Blazor model because they stay in the same tool chain they're used to and they're already familiar with. They don't have to learn Webpack and a bunch of the other tech that's required to make the client tech work. They can stay in C# as much as they want to. They're still interop with JavaScript if you want it. But we don't really have any opinion at Microsoft. A lot of Microsoft tech uses React. And so, we'll continue to make sure that there's great support for React, there's great support for Angular, and there's great support for Blazor. We do know that if, from a server side perspective, your .NET Server tech is going to be faster than Node.js. It's going to be faster than Java. It's going to be faster than pretty much any tech. If you're looking at a full stack, we'll be faster. Some of the other tech might have faster frameworks, but they are all. Can I pause for 1 second? I have a call I have to answer. I'll be right back.
Go right ahead.
Sorry.
We'll gather some questions.
Hello.
Hey, Scott.
So I just wanted to say here that he demoed some pretty new tech.
Yeah, and a lot.
almost all the demos went flawlessly. I was just waiting for stuff to crash and burn, but
yeah,
it went pretty well. Yeah.
There was a lot packed
Coming
in
a mile a minute, wasn't it? Ooh.
I know.
Yeah.
Everybody was on the edge of their seats. Here comes some new stuff. Oh, here's some more new stuff. Oh, here's new stuff.
I mean, we face that with clients. There's so many options now, and like, what do I pick? Right. And if you say, well, we think Blazor is a good path. Well, what about React? What about they second guess for weeks before we make a decision, and yeah, it's tough.
Right. I
Project
like his
Tye,
comments.
Good.
I like his comments there towards the end, comparing Blazor Server versus Blazor WebAssembly, because we were kind of leaning towards WebAssembly, I think, too. But I don't know. Might be interesting to try out both.
Yeah, I think it's a combination that will probably, be the solution of pretty much any project. Actually, Project Tye really came together in my head with this demo.
Oh man, I know.
That's awesome.
That was pretty slick. Yeah. Clint, are you guys doing anything with Tye? You're muted there, buddy.
You're muted. You're muted, Clint.
Yeah,
There
Jess
you go.
Likens, who spoke last month or month before last, he's doing a pretty good sized project with.
Oh, that's right. Yeah, that was you guys. Yeah, forgot about that.
Yeah, he digs it. I'm an app dev guy. I'll let somebody else figure out how it all works in the servers.
There's so much new stuff.
Give me a YAML script to deploy it, and I'll be happy. I don't want to think about it. So.
Right.
Of course, that's generated, like you said.
Yeah, so the tool can generate that YAML, and I don't have to go read the. I was doing that 2 weeks ago. That's like, painful, because with GitHub, the pipeline's kind of starting over, right? I mean, in Azure DevOps, it's been pretty well built out and documented, and now we're kind of starting again with GitHub, but it'll catch up.
Mm-hmm.
There's a Project Tye introduction on the web in the Microsoft. It's almost a year old, but still, there's no way I could take all that in at once. So it's going to be pretty interesting just to read through that instead.
Yeah.
Definitely.
Yeah. Somebody asked about microservices mainly used for large applications. I think they're useful for large domains.
Hey, folks.
Yeah.
Hey, welcome back. We're just checking out some of the questions in the chat.
Yeah.
Anything good?
I'll say.
Well, go ahead, Clint.
I'll say Andrew was asking about are microservices mainly useful for large scale applications? Curious what most situations people are using them for. I've seen them in complex domains. I think what's attracted to Tye is it lets you manage a large complex deployment with the support for monitoring it and dependency management. I mean, it's just it solves a lot of problems that people have to solve manually. It takes days to troubleshoot sometimes.
Yeah, right there by hand. Yeah.
I was going to say, for us, microservices, it's funny. In my couple of years of talking to customers about microservices, like 5 years ago, people came to us and said, we're going to take our monolithic application, we're going to break it up into 30 pieces. And they did. And then they had to manage 30 pieces, and they said, oops, that was a mistake.
Yeah.
And so what we find today is this is going to sound weird, when somebody says they're going to move to microservices, what it really means today is it means they're going to break a big app typically into like 2 or 3 pieces, not 30 pieces. And that's so they can have each of those teams work independently of each other. They're not really using the micro part of microservice. They're not going to make it like a bunch of 10-line applications and try to run them. It also typically means that they're modernizing and using modern DevOps. And so when we, Microsoft, go and talk to a customer, typically that means we're going to modernize to modern DevOps, and we're going to take our huge app and try to break it into a few pieces where maybe we can ship the front end at a faster rate than having to wait for the front end and the back end to go at the same time every time. So it gives them a little bit more speed.
Scott, I just want to let you know that we're still connected. And
I'm on a support call, so I'm.
Damn, Scott H does support. Wow.
Okay, sounds good.
You got to delegate that, brother.
Not a Microsoft support call. This is a home support call for
I see.
internet. So,
okay, that makes more sense.
Hi, I have a question.
You still got a pager attached to your belt there?
There's another question?
Yeah, I have a question on Blazor. So with Blazor, if we are going to do mobile app, okay, so how native it is going to be and how much access we have for native things on mobile, because some things like if I have an app and if I want to have connection to a external printer and I want to send something to my printer from the app, and how those things work with Blazor mobile app.
So that's a great question, and that's a fun question that's going to happen in the .NET 6 wave. So what we plan to do is we're going to add a Blazor WebView tag to a Xamarin application. And so what that's going to do is that's going to let you basically, if you want to build a Xamarin app, that's an iOS, Android, or Mac or Windows app, and you want to shove Blazor content into that, you'll be able to do that exact same thing. That'll give you a web-based Xamarin app. And as you said, the primary benefit of that is that means the Blazor app can talk to the actual Xamarin host, which means you have access to native APIs. So for example, and we have customers that have hand-rolled this today. There's a dry cleaners, that's a company you'll hear us talk about probably at Build, where they rewrote their entire app for their dry cleaner for both the service people and the customers as a Blazor app. But inside the dry cleaners, they needed their Blazor app to have access to the cash register. And so what they did is they actually took the Blazor app and they shoved it into a WPF application by using WebView 2, that same demo that I did on the desktop app. And then because it's a desktop app, it now has access to all the APIs. And so they were able to actually to do that. Now, what we're going to do is we're going to make it where you don't have to manually roll that together like they did. And in many ways, we're going to give you what, if you've seen what we call an Electron application.
Scott, thank you.
1 sec again, folks.
Pretty fascinating to hear what people are doing nowadays. That's crazy, crazy tech.
Yeah, this was this dry cleaner had written the entire app in VB years ago, and they made the leap from VB to a Blazor app, and then wrote it inside of the WPF app. And people have asked us before, how would you build an Electron app? In fact, at one point we thought we were going to actually have it where you could build Blazor apps using Electron. And then we asked ourselves, well, why would we make you boot up a JavaScript engine and all that other stuff when we already have a cross-platform host, Xamarin? Let's just shove it into Xamarin. And so as we get into the first previews of .NET 6 in February and beyond, probably by the build conference in May, you'll see me running a Blazor app inside of a Xamarin app, making a iOS, Android, Windows, Mac Blazor app that behaves like a native app, but you can write it in WebTech, which is great because you can share your UI across all 4 platforms using Blazor, but still have access to native APIs. And there's a feature in Xamarin called Xamarin Essentials. It's a piece of tech that kind of tries to abstract the native hardware. And so I can say, give me the GPS, and it'll do the right thing on a Mac or a Windows machine or an iOS or Android machine, so you don't have to make those native calls yourself. We think the entire, we call this type of app, we call them hybrid apps. They're a hybrid of web app and a hybrid of native app. And that'll be a big focus that you'll see us do in .NET 6.
Thank you.
You can hand roll it today, but it'll be in .NET 6, by default.
Okay.
So you get much closer to that write once, run everywhere model.
It is. It's amazing that back in the day it was Java servlets or ActiveX, and now with WebAssembly and some of the tech we have today, we can really almost get you to the right kind of place now. It's just the browser tech and everything else is kind of improved to a point that it's much better.
Nice.
So Scott, put on your magic thinking hat and tell us what's going to be in 7 and 8. What's on the long range burners? Or what do you wish would be there?
So it's actually a great question. That we ask ourselves this question all the time. In fact, I put a lot of pressure on my team that in many ways, our current journey, .NET Core 1 through .NET 6, in many ways is kind of a catch up. Hey, the industry moved and changed. We modernized .NET to be cross-platform, to work on fully open source, have WebAssembly, Blazor, microservices. We've checked a bunch of those boxes, and once you get past 6, you're kind of at a point where what's next, because you've done all the big stuff. I think the stuff that's going to happen in 6, and the way I'm going to say it today is going to be complicated. There's crazy ideas. WebAssembly. There's a chance that WebAssembly could be the universal way of writing all applications. You compile to WASM.
Thank you so much for waiting.
Back in 1 second.
He's teasing.
He's teasing us, right? That's right to the edge.
That's my hope too. John, you and I talked about that. If Angular and React can get to native WASM builds, then WASM is here to stay, right?
Right.
Not a lot of tech is using it, even though the browsers all support it. I think, and that's the Silverlight problem. If nobody ends up supporting it, it gets dropped from browsers in 10 years. But if everybody jumps on that, then there's a good chance that does become the ubiquitous platform that everybody compiles to. Then we're all, it's just, the future's wide open.
Yeah.
Right.
Then we're just dealing with truly languages.
Yeah, think of mixing Angular and TypeScript WASM DLLs with .NET. We're dogs and cats living together.
Yeah, it's possible. Yes,
it could. Yeah, I gotta believe somebody's trying to compile Angular and React apps and Vue apps and all the other platforms to WebAssembly. Somebody's got to be doing it. It's too attractive not to.
Yeah, especially if that performance really starts kicking in on WebAssembly, you're gonna want to. So
yeah, we got a biggest Angular app. It's 80, 90 megs all up with all the pages, you know, a couple hundred pages. And now we download it a little at a time, but if you were to traverse the whole thing, yeah, it's a pretty big footprint.
Mm-hmm. Yeah. It sure would be nice to see Blazor really kind of kick in. I really like what I see there, especially what he was just describing on the mobile side and how that could really come together.
I got a client using Blazor for several projects now in production use. One of which is SharePoint add-ins because they don't want to write it anything else. So
okay. So I'm back. Final time. That was the last of that fun stuff. Yes, I think the WASM thing is interesting because maybe it's a way to run containers. I'll throw something out there that I think's not that far out. I think ARM support, ARM64 support. I think we're at a point where you're going to see, you know, you have to give Apple a lot of credit by releasing amazing chips with the M1 chips. You're going to see, you know, there's already ARM Windows PCs. Amazon has ARM in their cloud. You have to assume ARM's going to come to our cloud. I'm not saying anything. I'm just saying that's my, you know, I don't know anything. I'm saying I don't know. I'm just assuming. And I would not be surprised to see custom ARM chips for Windows. You know, when you see, for people that have not seen it, a MacBook Pro with an M1 ARM chip will run for 20 hours. There's no fans. And if you run the MacBook Air, there's no fan in the dang thing. So it can run fanless. It's instant on, 20 hours of battery life. We have teammates that can run Microsoft Teams for 8 hours and be at 80% battery life after 8 hours of Teams. So I think there's a fundamental shift that's going to happen. And the ARM tech does that with a variety of things: small cores, big cores. You know, when your machine's not super busy, it moves to really small and cheap cores. Expensive things run on big cores. Apple also put other processors in the chips, and so I think you're going to see a ton of, you know, as I said, for .NET 6, you'll see ARM64 support for WinForms and WPF. We already had WinForms done in the .NET 5 timeframe. WPF was a little longer because it had more native tech. So I think ARM is going to be interesting. I think WASM is going to be very interesting. Another thing that's as we think of the cloud, you've probably heard the term edge computing. And I think, how do we make .NET an awesome tech for edge computing? And to help with that, you know, think of like image detection. Let's say you had a camera somewhere and you wanted to detect the number of cars in a parking lot, for example. Well, you could take that whole image, the big image from the camera, ship it down to the server, you know, 8 megs each or more, process it on the server and send the result back. Or what you do is you put the image processing actually at the edge and then ship the result of what it finds to the server. So, you know, other apps can see that. That's edge computing. And so that's like taking your workload and breaking some of the expensive parts out and running them at different parts of the network. So I think that's a space that's going to require frameworks to help you, because that's what I just described sounds complicated and a bunch of plumbing to hook up. And our job is kind of to help with that type of plumbing. And so I think that's going to be interesting. You know, the linker tech. You know, I showed how to make linkable projects, or how to make a single exe and make it small. One of the problems that all languages like .NET have is that we have things like reflection. And so it's very difficult in some cases. We can link stuff away and then find out your app doesn't work. And so you're going to see us do a lot of work to hopefully enable our component ecosystem to attribute their frameworks in ways to make the linker tech easier, safer, better to use. I'll throw another one out that we'll announce next month. Does anybody here on the call know what the diamond problem is with packages in .NET?
No.
You do. You just don't remember it. So imagine this. You write your application and you decide to use John's super package. So I'm going to use John's super package. John's super package uses an old version of JSON.NET. My project is using the latest version of JSON.NET. As soon as I try to reference John's package, .NET goes, nope, you can't do that because there's two JSON.NETs. And so this is a common problem that we have. JavaScript doesn't have it because JavaScript's typically source code. And so with source code, you can fix this stuff. Because .NET is precompiled, it's hard to fix it. So we actually have a whole team looking at a bunch of experimentations to make sure that we can solve this diamond problem in the .NET package ecosystem. And this comes up all the time. If you use an Azure SDK, well, the Azure SDK team has to choose which version of JSON.NET they want to use. And then maybe they get a complaint saying, well, you're on an older version, we're using a newer version. And then you have to wait for the next Azure SDK to support that newer version. What if we could fix that for you? So I think that the diamond package problem is another problem that we will look at. And then probably the final one, and I said that I know I'm not kind of all over the place. One of the things that Apple has done in their ecosystem is they have something called Swift UI, and this is Flutter is doing something very similar. You know, we all started with these ways of describing native UI using XML or some form of markup, XAML, XML, and we're now going to more of a code first kind of experience. And so that's a whole place that we're looking at in .NET as well. Is it easier to write your UI? And we have a sample project called Project Comet that does this today, where you write your UI in C#. Well, if you try that, it's too verbose. But guess what? I own the C# language too. I can change the language. And so do we go change the language the same way we did it for Link to do that? So some variety of all that stuff I just talked about is likely going to be in the .NET 7 waves. You know, better linker, you know, better ways of doing edge computing, UI and code, WASM, IoT will be more of a thing as well. But literally what we kind of do is we kind of sit back and watch and see where the market goes. And when the market jumps somewhere, hopefully we're thinking about everything enough that we're not too far behind. WASM was one of the things that I'm very happy about. We were looking at WASM before it was, you know, there was a Blazor. And so when a Blazor came, it wasn't that hard for us to boot that up. And so we try to make sure that any of the things that you kind of hear in the tech space, we're looking at and making sure we are experimenting enough that it doesn't take us 2 years to boot them up.
Hey, Scott, do you have any insight maybe where Office is headed? Meaning that, you know, I always pine for the day that I'd have an Access version of .NET. I know other devs laugh at me, but I tend to use that tool quite a bit to get some work done really quick. So, you know, it would be nice if I was able to use some .NET a lot more efficiently. I know you can, you know, hook into the different Office apps, whatnot, but it's, you know, it's just not really part of the .NET ecosystem like I think most developers would want it to be. Do you see more, I don't call it integration even, but more really tightly coupled aspects being there?
Well, I'll give you the joke. There's two ways of programming Office today. There's the Office extensions for .NET,
mm-hmm.
and there's their JavaScript libraries.
Mm-hmm.
Do you want to know which ones are used the most?
Oh, the first, I think.
Yes.
Yeah, by far.
By such an extent, the JavaScript libraries are actually a fail.
Mm-hmm.
That nobody uses them, and anybody doing anything is using the .NET things. That brings up an interesting problem for me. If you're on an ARM version of Windows, that means Office, when it loads up, is likely to load some of these .NET extensions for Office, and it's gonna go run an emulated version of .NET Framework to make that work. And so doing an ARM 64 version of .NET Framework is something we are looking at to solve that particular problem. If you look at the Office extensibility moving forward, where they're using some more web tech in a few places, the one I think of actually, and this is something I should have mentioned before, we're looking at this now, is Teams. You know, we're all sitting on a Teams call right now. If I come over here, let's see if I can do one of these things. They keep moving this crap around. I don't know where it.
I'm glad you're as frustrated with it as we are.
We feel you.
I'm probably worse than you because I get bills shoved at me that you at least have to wait for the public ones. I don't get a chance to wait for the public ones. I just get whatever punishment they decide to send me for the day. I'm making fun of ourselves, by the way, so don't. In fact, there's a notion.
This is recorded for your sake.
It's not letting me do what I want to do, but there's these notion of apps in Teams. I don't know if you've seen it. There's a little thing you can normally click, and there's a variety of apps. And we are going to look to make the app ecosystem inside of Teams much bigger. And so part of our org is building the developer tools to make the plugins for Teams that can be in the Teams app model. And we'll make sure there's a .NET way of doing that. The .NET way of doing that will obviously be Blazor. And so we'll host a Blazor app inside of Teams. Those same apps likely will also end up showing up in Outlook as well. And so I think you're going to see Teams and Outlook. Teams already has the model. It's just hard to program. We're going to make it easier to program. We're going to make .NET be able to be in there. And now I think it's going to be very, very easy to write add-ins to parts of Teams and parts of Outlook. Pisses me off. The option's not here. Maybe it's because we're on one of these group calls. So that's a whole space that we're looking at investing in as well. And that'll be sooner than later. That won't be .NET 7. That'll be before .NET 7. You'll see that this year probably. You'll see the tools for Teams, and then we'll make sure there's a .NET way of doing that stuff. Another area, speaking of that's a huge area, is obviously Power Apps is a very interesting play for many of our customers. And for folks who don't know what Power Apps is, kind of like it's a WYSIWYG for building apps without having to have a lot of programming knowledge. And something we shipped in November, a lot of the API improvements we have in .NET were actually pointed at Teams. Pointed at Power Apps. We want to make .NET Power Apps a Power App can easily call into your .NET backends. And we're doing tech here. There's one right there. He's showing the apps that you can shove into Teams. And we will make those easy to write those in .NET. But we want to make Power apps very easy to call into a .NET backend. And so we did work that it'd be hard for you to find out about today, where you can actually, from a Power Apps, you can call a .NET API, and we'll actually flow your identity down to the API, and you can actually make Microsoft 365 calls in the web API on behalf of the Power App user. And that takes one line of code to do that. That used to take hundreds of lines of code. So I think you're going to see us shove .NET into all the Power App space. You're going to see us shove it into the Teams space, because we see those spaces as areas that Microsoft customers are going to grow in a lot, over the next year. My kids, go to school in Teams right now, so.
Yeah. Scott, this has been a really fascinating user group meeting. Thanks for coming and sharing all this.
I really appreciate it.
I have a personal question for you. We're kind of playing with Databricks now. Do you see any kind of integration or any changes with your team into Databricks and the tooling around that whole environment?
The big stuff that we do in that space is, there's Databricks and probably the Microsoft equivalent. You can run Databricks in Azure. They're a big partner of ours. Azure Synapse will do a bunch of the same stuff that Databricks does. The big thing that we've done from a .NET perspective there is we have our .NET support for Apache Spark. And that's something you'll see us continue to drive forward. That's the big data .NET kind of hooks. And that's primarily where you're going to see us invest, is if there's an Apache Spark instance, we're going to make sure that .NET can play in that space really well. That's something we did actually internally. This is going to sound really weird. We have something called Cosmos DB, not the Cosmos that's in Azure, but we have our own Cosmos. And that is the data engine that powers almost all of the telemetry and telemetry information we have inside of Microsoft. So it's how we know how many Azure customers there are, how many Visual Studio customers. It's all into that instance. And we attempted a couple of years ago to basically try to move off of that custom tech to Apache Spark. And then a lot of the teams that actually write stuff for that tech are writing it in .NET already. And so we wrote the Apache extensions for .NET, so it'd be easier for them to move their code over. And then we decided, hell no, that was a terrible idea, because Cosmos has its own feature sets that are very different than Apache Spark. And it would have taken 100 years probably to actually migrate the whole thing over there and get the same capabilities. But in fact, this is I think we publicly said this. Our Cosmos is probably the biggest project running in Azure all up.
Oh wow!
It's probably the biggest Azure customer in the world. I don't know how many VMs they have. I'm afraid to know. I just know they have a ton.
So what you do in Cosmos on your side?
But that's not Cosmos DB, just to be clear. That's
Yeah. So from as you said, Microsoft itself is a big customer for Cosmos. What Microsoft is doing in Cosmos?
The Cosmos DB that we have in the cloud.
No, you said a Cosmos separate one, is it right?
The Cosmos one, that's a private thing just inside of Microsoft. That's not for the public.
Okay.
That's just basically the analytic engine that we use behind the scenes to run all the reports across all the Microsoft businesses.
Okay.
And just imagine, it's been around for 20 years, so it's deeply ingrained in everything that we have.
Just one question regarding the Blazor. So from your standpoint, looking at the backlog for Blazor, how much thing you think Blazor has? Like it has like 80% of features now, or what's your estimate on it?
I would probably say it probably has 85% of features. We're really looking for feedback from customers to see what's missing. So what we kind of do release to release is we go look and customers say, well, I had like I mentioned the dry cleaner, and they showed us like 3 things they had to write in JavaScript. So Blazor and .NET 6 will remove those 3 things they had to write in JavaScript. And so our kind of goal with Blazor is to make sure, number one, we have awesome JavaScript interop, and then number 2, try to make it where customers don't have to drop into JavaScript for things. But areas of improvement in Blazor, the most awesome area that I can't wait for in Blazor is going to be today. What we do is parts of .NET are precompiled, which means they run as native WASM. And then parts of your app, mainly your code for the most part, runs through an interpreter, which means we cannot run at full performance. And we do that because if we compile the entire app into WASM, it would become too big. But what I'm excited about, and hopefully we'll get some of this in 6, is we're going to let you attribute your code and say, I want this code to run native. And that's when Blazor is going to start having a big one-up on JavaScript, because whenever you put that attribute on your code, it's not going to run through a .NET interpreter running on WASM or run in JavaScript. It's going to run native. And so I've got a benchmark we've not ever shown anywhere where we actually show Fibonacci, and we run it in both JavaScript, we run it in .NET interpreted, and we run it in .NET native WASM. And that's going to be super exciting, because then you're going to get C++ performance in the browser with WASM.
Wow.
Yeah, that's a big deal. Wow.
Adobe has actually shown a version of Autodesk. That's their CAD tech. That's a C++ app, and there's a C++ WASM converter, and they got most of Autodesk running in the browser, primarily at native speed. Once you have a canvas, you can just paint to the canvas pixels, just like you do, on a on a desktop machine. So that whole space is going to be super interesting. We have to go and see how it's going to turn, but it's interesting. We call it the democratization of the browser. You don't have to be locked to one language. You can use the language of your choice. What I would always say is use the language that's the right language for what you're doing. If you have 100,000 lines of JavaScript, 100,000 lines of .NET, you shouldn't have to port that to JavaScript. If you have 100,000 lines of C++, you shouldn't have to port that to JavaScript. If you have 100,000 lines of Java, you shouldn't have to port it to JavaScript. Use the tech here that's best for your job.
Well, thanks, Scott.
My wife's going to start calling me for dinner, folks.
No, I was going to say thanks. I think this is a great place. Let's wrap this up. I really
hope
appreciate
this is what you were
time.
looking for. So I like these just to be kind of just do a bunch of demos and then kind of hang out and just chat. So
Absolutely.
Yeah, this was more than expected, and definitely appreciated. So
yeah, I think if you can revisit us maybe at least once a year, it will be great.
I'm happy to come by once a year. So if you have me back next January, and we'll talk about .NET 6 and .NET 7.
Sounds great. We're going to hold you to that.
Please do.
We want you headlining our conference in the fall.
I mean, hopefully at some point in the future, there's no COVID anymore, and we can actually travel and see each other in person again. So I'm actually, I used to complain saying that I flew too much, and I was going to cut it back. I didn't know cut it back meant to 0.
Right.
All right. Well, thanks, Scott, and thanks, Clint, for the lightning talk, and thanks
guys.
everyone. And this will be posted up on YouTube. I'll put a link in the Meetup post for the recording.
Thank you,
folks.
guys. Good night.
Good night.
Thanks, everyone. See you.
Thanks.
Thanks, Scott.